Before we start this video, a large thank you to Friday, Kyle John, Laura Walker, Alfredo, Stormy Blue, and Zinan for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner and Ryan Bellin for their immense support of the channel this month on Patreon. It is always sincerely appreciated, gentlemen, and I hope you enjoy the video. Hello everybody, I'm going to go into my scenes folder in a brand new project and change the sample scene to world, and this is in Unity 6.2.1 to F1 if you want to get very specific and use the same version as me. I am going to first begin by creating a script, and we're going to call this world scene manager. And I'm then going to make another script, and we're going to call this world location manager. And then I'm going to make one more script for now, and we're going to call this a world location. So the way this is going to work, as I stated in episode 0, is we're just going to basically have these locations as scriptable objects. So let's begin by going into that script. I'm going to delete the start and update functionality as is per tradition and drop in my namespace. Mine is SG. And I'm going to make this derive from the scriptable object class, so we can use it as a scriptable. And of course, I'm going to create an asset menu so we can actually make this in the project. So I'm going to say menu name is equal to, and we'll just say world location. So for those of you who watched the episode 0, this world location is going to consist of scenes that make up this one location. So let's make a header and say scenes required. And we're going to use a list of scenes here. So we're going to say public, and because I'm using a list, I have to come up here and say using system.collections.generic. Public list of string being the scene name, and we're going to call this scenes required for this location. And we're going to initialize that as a new list. Right below that now we're going to say header, and we're going to say locations required. So every location might have another location attached to it, almost certainly actually, that needs to be loaded in as well. Why is this? So let's make an array of these world locations. Let's say you're in area 1, but in the distance there's a tower, and that's area 2. Well, you need to have area 2 loaded in because you can see it from area 1, or at least something that's similar to area 2. Maybe you got some trickery going on and you load in like a dummy scene, but both still have this circumstance where you need another location loaded in. So the top one is a list of scenes that require to make this location. The bottom one is a collection of other locations that have to be loaded in when you enter this one. So if I'm in area 1 and I can see area 2 and 3, I might want to have those loaded in at the same time. So those become required. Now let's come out here and make a public list string, and let's call this get all required scenes for this area, or this location, sorry. So we're going to use this function to basically get every single scene we need to load if you walk into this area. So I'll make a comment up here, get all scenes required when this location is loaded. So let's say you walk into this location. It's going to access this bit of code, and it's going to get every single scene you need for this location and for every attached location to this one that you need to load. And we'll put them in a list basically and load them one by one. So we can start out by saying right here we can use this variable. Let's make a list, and let's call this total scenes required for this location. And we can start by iterating through our scenes required for this location and just adding them to that list. So this is just the scenes for this specific location right here, this first variable we made. So let's iterate through that. I'm going to do a for loop here. We're going to say dot count because this is a list. And normally if this wasn't just a string value or something I'd check for null, you should always do that in your for loops, but I'm not going to. This is just going to be a list of string values, so I'm going to put these in manually. Now, right below that, let's make a comment first. Actually, first get all the scenes in this individual location and add them to the list. And then right below that, we're going to do a for loop. We're going to iterate through our locations attached to this location. But inside that for loop, we're going to do another for loop. So let's make a new list inside this for loop. And let's say scenes required for this attached location. So remember now, we're iterating through every attached location that you need. And then we're going to iterate through all of them with a nested for loop. So we're going to do for j, and then we're going to paste locations required for this location, but we're going to use I. So basically, we're going to go through every required location, and then we're going to get all the scenes from those locations and add them to the list. Sometimes a nested for loop can look a little bit confusing, but that's essentially all we're doing. We're going through every attached location, and we're getting that first variable we made up there, the scenes, for each of their individual locations. And if they're not on the list, we're going to simply say scenes required for attached locations.add. Okay, so right below that, let's do one more for loop. And what we're going to reference now is the scenes required for attached locations. That's the one we just made in here within this for loop. And we're going to say if our total scenes do not contain the scene that we added to this scenes required for this specific attached location, we're going to add it to. So we're just doing a check basically to make sure that this scene has not already been added by another required scene, because sometimes you might have an area in your game where there is some overlap or a shared scene. Okay, so now I'll add a comment. Next we check all the required locations and we add their required scenes, and then we make sure not to add a scene more than once. It's not a big deal if you do, because we can just skip over it in the process of the loading a scene, but if you have a buffer time in between your loads, you'll notice a slightly longer buffer, so let's not try to add it more than once. Okay, and lastly, we can just return this list of total required scenes for this location. All right, now one more function on this script, and it's very simple. We're going to say public list string, and then we're going to say get do not unload list for this location, and all we're going to do is return the scenes required for this location. Now, why are we doing this? Well, when you go to a new area, it's going to unload every scene that you don't need, but we're going to keep a list of scenes that are required by each location that is loaded into the game, and the game will know not to unload those for us. So that's it, we're done here. Now, we need to get netcode for game objects. So go to your package manager, because this is a multiplayer tutorial, and we're going to go and get netcode for game objects. So let's go and search netcode in Unity registry, and we can see here it's 2.7 is the current version I am using. So let's install that. When that's done, go over to your world scene manager, delete the start and update functionality, and drop in your namespace as is per tradition. And I'm going to start by making this derive from a network behavior. So this is, you have to say using unity.netcode if you don't get that, by the way, up top. We're going to say public static world scene manager instance. Let's make this a singleton, and we're going to get the awake method here. And we're going to do a very simple, if the singleton is equal to null, singleton is equal to this, else destroy this game object. So this is basically going to handle all of our scene unloading and loading, and the events that will come with scene changes. So because we're using netcode, the only real difference here, to my knowledge, is that we're using the netcode scene manager, not Unity's regular scene manager. So we're going to say don't destroy unload after all that too if we pass the instance check. So let's use a header for world scene, and this is the scene that's always going to be loaded after we leave the main menu scene. Public string world is equal to I called mine world, as you saw in the first of the video. This will be a scene that is always loaded when you leave the main menu scene. So the world will always load in around this. This scene just always has everything consistent. Now I do this in my game, I put the sky in there and other things, but what's cool is you can have multiple world scenes, and each of those worlds can have their own locations. But I won't get into that now, that's outside the scope of this video, but that's why I do a world scene manager and a world location manager. Now, next I am going to make an override on network despawn and spawn, and we're going to do a call here. We want something to run every time we do something with a scene. So we're going to say network manager dot scene manager dot on scene event plus equals, and I'm going to hit tab. It should auto-generate if you do the same thing, this function right here. And I'm going to rename that to, we can actually just call it on scene event. That's a pretty good name because it's going to fire every time a scene event happens. Now I'm going to erase the default logic, but first I'm going to paste this on scene despawn and say minus equals so we unsubscribe from it when this network object despawns. Okay, so down here I'm going to say scene event. We're going to switch, the scene event dot scene event type, and then we'll get this nice switch statement where you have all these events. They fire whenever, for example, load fires when the scene is loaded, unload fires when it's unloaded. Load event complete, I believe, is when everybody has a load event complete on the network. The same for unload event complete, but in reverse. So come up here, let's make a header for scene loading. And I'm going to make a serializable private bool for is loading a scene is equal to false. I'm going to do the same thing for is unloading a scene. I want to know when we're doing both because they are a bit different in terms of how you're going to set stuff up if you want to add things like AI. But again, I won't get into that either because I'll just show you why it's important in the scope of this project. So private int loading queue, we're going to keep track of how many scenes we're loading as well, and we're going to keep track of how many we're unloading. Because with the scene manager, the network scene manager, you have to load them one at a time. You can't send multiple load calls in at the same time. So we're going to put them in a queue. Now let's go and make a private list. And I don't know why it's giving me n unit framework. So we're going to say public list string. We're going to say do not unload scenes is equal to a new list. And before I say this, I need to go up here and change this to system.collections.generic. So I'm going to say that. There we go. Equals new list string. There we go. Now I'm going to copy this header, paste it here. I'm going to make a header here for do not unload list, just so that's on its own a bit more clear. I'm going to take the time here to really make everything nice and neat. I'm going to copy and paste this. I'm going to make this header called currently loaded, and we're going to make a new list, and we're going to call this scenes, or loaded scenes rather. And this is going to be a list of all the scenes you have loaded. I'm going to change the type to scene. Now I believe defaultly you can't see this in the inspector. It just shows an entry in a list that doesn't show the actual scene information. I could be mistaken, but we'll see that momentarily anyway. So I'm going to hide this in the inspector for now. If you want to erase that to see if you can see it, go for it. But I don't think you can see serialized scenes in Unity's inspector by default. Now I'm going to come up here and paste this list of do not unload scenes and change it to queued load scene IDs. And then we'll make one for queued unload scene IDs. So this is going to be a list of scenes you're attempting to load and unload. And as you would guess, we're going to send a list of scenes to this script. It's going to go through them and load them one by one or unload them one by one. I'll make that serializable too so we can see it. And now I'm going to copy this header and I'll put down here, we'll call this scene queue. And then above we have scene loading, and that looks nice to me. Now I'm going to do another variable, a private coroutine. I'm going to call this scene loading coroutine, and then another coroutine for scene unloading coroutine. So we're going to manage all this via coroutines. Okay, now down below here, I'm going to make a comment, trying to keep this as nice as I can, loading our scenes, and we're going to have 3 functions for loading and 3 for unloading. So the first one is going to be a public void load world scene. Actually, sorry, 4 for loading. This is the function you're going to call from your main menu, or at least this is how I do it. So this one just gets us into the world scene, and that sets this scene as our active scene. So we're going to say network manager.singleton.sceneManager.load scene world, as in our world scene, and then we're going to load scene mode single. And this is going to make this basically the main scene in the game. So if new game objects get instantiated, they're going to pop into this scene. And now right below that, we can actually get the functionality for our additive scenes, which are the scenes that are going to be basically brought up and then taken down again as we move through the world. So first, let's make a private void for load additive scene and make it require a string for the scene name. So basically, we're going to pass a scene name to this, and it's going to load it for us. What do we do? Well, first off, if we're not the network manager.singleton.isServer, when we're not the host, basically, return. Depending on how you set it up, it should never run anyway, but if you're going to set it up where this could accidentally be ran, if you're not the host, return. Otherwise, you will get an error. Only the host should be able to change the scenes because the network manager syncs the scenes for us with connected clients. Next, we're going to do a for loop, and we're going to go through all of our loaded scenes. And if for some reason, somehow, loaded scene I is equal to null, we're going to simply come down here and say continue. We're going to say if loaded scenes I dot name is equal to scene name and loaded scenes I dot is loaded, we're going to return because the scene is already loaded, so we don't need to load it again. Now I'll make a comment up here too, just so this is all clear. If the scene is null, simply continue onto the list. Because what we're doing here is we're checking our list of loaded scenes to see if we already have it loaded, if it's there. So if one matches the name and that scene is already loaded, return. We don't need to load it again. Okay, so if the scene is equal to the scene name we are trying to load and it is loaded, return. All right, what's next? Well, outside of that for loop, if you pass that check, we're going to say is loading scene is equal to true, and now we're going to start a load call. We're going to say var variable scene load is equal to network manager dot singleton. Whoops, sorry, it's supposed to be dot singleton dot scene manager dot load scene. We're going to pass the scene name, and we're going to pass load scene mode additive. So we're using additive here instead of single, and this is going to load the scene additively into the world. Okay, cool, but that only loads one scene. Now we load a bunch at a time because we're doing this by lists. Well, let's make another function that's going to be public this time. Public void load additive scenes and make it require a list. And now what we're going to do is use this function to go into a coroutine, and we're going to call this load additive scene one by one while we iterate through them. So first off, do a check. If you're not the server, return. And then we're going to do a for loop, and we're going to loop through the scene lists that were given to this function for it to run. And then we're going to say if queued load scene IDs dot contains scene list I. So basically, if any scene in our queued load scenes contains the scene already, continue. We don't want to add it. If the scene is already in our load queue, don't add it again, simply continue. If not, we're going to add it to our load queue, just like so. Okay, and then we're going to say loading queue amount is equal to the queued load scene IDs dot count. And then we're going to say if the loading, what did I call that? What's the coroutine name? Oh, okay, here we go. Had to paste it. Lost it for a second. If scene loading coroutine does not equal null, stop the coroutine, because we're going to run it again with the new updated list. So the coroutine is going to be what we use to actually load in these scenes. It's going to fire the functions after a buffer time. So we're going to say scene loading coroutine equals start coroutine, and we're going to pass a name that doesn't exist yet, but we're going to make it right now. So first I'll make a comment though. If we are already running a scene loading coroutine, stop it, because now we have an updated list, so we'll run it with the updated list. Okay, nice and clear. Make sure you have the variable name here. Make sure you're checking for null, by the way, because if it is actually null, then you'll get an error if you try to stop it. So let's make a private enumerator, and I'm going to call this load additive scenes coroutine. And this is going to iterate through the scenes we pass to our queued load scene IDs, and it's going to attempt to load them. But you can see here it's giving me grief. So what I'm going to do is come up here to the top and say using systems.collection, or rather system.collections. Now down here in our coroutine, I'm going to say float wait time is equal to 0.1f. I find this a pretty good time. I handle some pretty big scenes in my project, and 0.1f has not given me any stutters, so we're going to make a comment here for check if the player is in a loading screen or something of that nature, and if so, just change the wait time to 0. So for example, if I have a wait, or rather a loading screen in my game, I don't have any wait time. I just load them all immediately after one another, because a stutter doesn't matter if you're not going to see it if a loading screen is up. So let's do a for loop, and we're going to go through each of the queued load scene IDs.count, and we're going to say while we are loading a scene or unloading a scene, we're going to simply yield return new wait for seconds, and we pass the wait time. So we don't want to try to do anything if we're already in the process of loading or unloading. Then we're going to say if queued load scene IDs I is equal null, well, we want to actually say loading queue amount minus minus, deduct for it, and continue on to the next scene. Alright, now up here I am going to make a comment while something is already loading or unloading, wait, and right here I'm going to say if the scene is null, just simply deduct from the count and continue onward. So basically we're iterating through all of the queued loading scenes, and we're going to attempt to load them one by one, which gets us to the next part of this. If we make it past all of this, we're going to say load additive scene, and we're going to pass the queued loaded scenes I, or queued load scene IDs I rather. And then again, we're going to wait for it to finish loading, and then we deduct from our counter by saying loading amount minus minus. And then lastly, we're going to check to see if that loading queue amount is less than or equal to 0. And if it is, we just want to simply clear the list. So we're going to say queued load scene IDs.clear. And that's basically it for the coroutine. The last thing we do is make the coroutine null by saying scene loading coroutine is equal to null. So now we can actually also call this coroutine. So first I'm going to paste this here as equal to null, and now I'm going to go up here and copy the name of the coroutine and paste it in our start coroutine call. Okay, that looks good. So now we're going to do all of that, but in reverse. But there is something that's slightly different in the onloading scenes, and I'll get to that when we come across it in the coroutine. But for now, I'm going to position my load additive scene function, whoops, not right there. I'm going to put it right at the top, right below load world scene. So we're going to do this in the same order. We're going to make onload additive scene, onload additive scenes, and then we're going to make onload additive scenes coroutine. So I'm going to make a comment here for onloading. I'm going to make a private void onload additive scene. We're going to make it require a scene name. I'm going to open these curly brackets here. I'm going to copy yoink my if we're not the server return. I'm also going to yoink this for loop here because we're going to need to go through the loaded scenes as well. Now, the thing I'm going to change is I'm going to make a for loop right above that for loop that is pasted, and we're going to go through our do not onload scenes. Because if this scene name is already in our do not onload scenes, we don't want to unload it, so we're going to return. So we're going to say if scene name is equal to do not unload scenes I, return. Don't go ahead with this function. That should be equals equals, or else Unity's going to give you grief like me, not a single equals. But yeah, if it's in that list, don't unload it. Let's make a comment so it's actually clear. If this scene is in the do not unload list, do not unload it. Otherwise, we're going to go through the loaded scenes list, and if the loaded scene does match the name and it is loaded, well, we know we can begin to unload it. So let's open up some curly brackets here. Whoops, didn't mean to delete everything there. There we go. All right, then we're going to say is unloading scenes equal to true, and we could say variable is equal to, and we're going to unload it. I'm going to change the comment here so it actually makes sense first, though. Man, there's memes about programmer comments just saying the name of the function, and sometimes it's true, but I don't know, I still find it helpful. Okay, so I'm going to say if the scene is loaded, unload the scene. The variable scene load is equal to, I think you could just say network manager.scene manager too, instead of referencing the singleton. You can. Well, I've already begun using the singleton, so I'm going to do that because I have to keep the naming consistent or else it bothers me. So we're going to say onload scene, we're going to pass loaded scenes I. Now right below that, we're going to say public void onload additive scenes, and we're going to make it require a list again, just like before, of string. And we're going to call this scene list. And now, much like before, we're going to check to see if we are indeed the server, and if not, we're going to return. And now right below that, we're going to say for, do a for loop here, and we're going to iterate through our scene list.count. And then we're going to say if the queued onload scene IDs dot contains scene list I, so if we already have the scene in the unload queue, continue, don't add it again. And I'm going to make a comment here, again, if our queued unload list already contains a scene, do not add it again, we don't want to attempt to unload it twice. Otherwise, we're going to add it to the queued unload scene IDs by saying queued unload scene IDs.add, and we pass the scene list I. Then we're going to say onload queue amount is equal to queued onload scene IDs.count. All right, very good. Right below that, we're going to say if onload scene queue amount, if scene loading unloading scene coroutine does not equal null, stop coroutine scene unloading coroutine. Then we're going to say scene unloading coroutine is equal to start coroutine, and just like before, now we don't have this function made yet. So we're going to copy the loading scene coroutine and paste it, but I'm going to delete most of this just so it's not confusing to you, and we're going to rewrite it anyway, save for the wait time, which I will keep. We'll put it at 1 second, and I'm going to eradicate basically everything else in here, except for this for loop, which I will change from queued load scenes to queued unload scenes. Now I put my onload wait time at about 1 second to 0.5 seconds. I don't know why, and maybe someone in the comments has an answer for me, but I find the load operations tend to be more expensive, but only the second time around they've went off in your project. Basically, the first time I unload scenes, it's not that expensive, but the second time, if the scenes aren't broken up into bigger spaces or smaller scenes, I notice there tends to be a larger spike. Anyway, we're going to do this while scene is loading or unloading wait, but then we're also going to do while the loading queue amount is greater than 0, we're also going to wait. Now, why are we doing this? Well, basically, we want to not unload scenes until all the scenes that are trying to load have loaded first. So the unload is always the second priority. So other than that, it's pretty much the same, but on the inverse. And again, I find a wait time between 0.5 and 1 works if you have very dense, heavy scenes. You can put it much smaller if your scenes are more lightweight, though. And again, this is all hardware dependent, so do some tests on your own. If queued unload scenes I is equal to null, we're going to simply say onload queue amount minus minus and continue. That's the same thing we do for loading, but the inverse. And then we're going to say unload additive scene, and we're going to pass queued unload scene IDs I, and then right below that, we're going to again wait for the scene to finish unloading. And then we're going to minus minus our unload queue amount. And then just like up top, but on the inverse, if the unload queue amount is less than or equal to 0, we're going to clear the queued unload scene IDs list. So we're just going to say queued unload scene IDs dot clear. And then we're going to say, what do I need that coroutine? I keep forgetting. Scene unloading coroutine is equal to null. It's because I'm looking at my other project and have it named something else. All right, so I'm just going to quickly put this coroutine name in the start coroutine, and I'm also going to go up and change this if statement to save a line of code, because it's going to bother me if I don't. So I'm going to save this. And after saving it, I'm going to scroll up here and go to my load queue amount and just make this a line shorter, because that was bothering me. There we go. And now I'm going to save again. Okay, so now I'm going to open up the on scene event. And now we're going to utilize the load event complete. We're going to say loaded scenes, and we're going to say add dot scene event dot scene. And then we're going to say for, and we're going to iterate through all of our loaded scenes. We're going to say loaded scenes dot count, and we're going to check to see if anything is unloaded. So we're going to say if loaded scenes is not loaded, loaded scenes remove at I. And then we can just write down here, say is loading scene is equal to false. So the load event complete is called when both people, the host and the client, or any clients that matter, have all finished loading the scenes and the network has synchronized it all. So we're going to do the same thing on unload event. We're going to come down here and say for. We can do a for loop here. We can just copy and paste this actually. We're just going to check to see if any scenes there are not loaded, and if not, we're going to remove them from the loaded scene list. And then we're going to say is unloading scene is equal to false. All right, great, excellent. And that's all we need in here on the on scene event. And you can utilize those other events for some stuff if you want to. They're very useful. Now I'm going to go into my world location manager, and we're going to start writing some logic for this. So let's make our namespace and erase our start and update functionality as is per tradition. And I'm also going to make a new script called the player manager. Now, this isn't important to the series, but I need a way to tag the player in some capacity for the example I'm going to showcase. And I'm sure you guys all have something that is your player's manager, that houses your player's controller or colliders, but just pretend that this is that for now. So this is going to be basically mostly empty. It's going to house a collider in one variable, but we're going to pretend it's our player. Now let's go to the world location manager again and make a private dictionary. And we're going to make it a dictionary for with a key of world location and a value of a list of player managers. So what this means is that each world location is going to have a list of players in it. And we're going to say players in this location is equal to a new dictionary, world location, and a list of player managers. So basically each location has a list of players. And if there's any players in it, that list will have a population of the players currently in it. It's just going to keep track of who is where, basically. Let's make this a public static world location manager instance, and we're going to call awake, do the same thing we did before, basically say if instance is null, instance is this, otherwise destroy this game object. Now, I don't use do not destroy on this. The reason I don't do that is because I have multiple worlds, each with their own location manager, which is why I do it this way. But again, this falls outside the scope of the series, so I'm not going to get into why I do that. But if you want to have multiple worlds, you need multiple world location managers for those worlds. So for that reason, I'm going to set it up like I've done if you want to basically make a world with multiple worlds, quote unquote. Now I'm going to say public void add player to new location. We're going to make this require a world location and a player. We just made the variable for that, the player manager. And what this is going to do is we're going to basically find the location we want to add it to and add them to that specific place. But we need the inverse too, which is remove player from location. So we have this function right here now for remove player from previous location. And I'm going to say if players in locations dot contains key. Whoops, I'm in the wrong function. I thought this was add because I just noticed I didn't type out the name correctly. Okay, so this is an add player to new location. If players in location does not contain the location, then we're going to say players in location location is equal to new list player manager. So basically, if our dictionary doesn't contain the location we're trying to send, we want to add it to that dictionary and give it a new list of players that's obviously going to be empty at the start. Then, after we know we have it now, because we just added it if we don't, we're going to say if players and locations, and we're going to reference the specific location we passed, does not contain the player. So we're going to use contains. We're going to say players and location add the player. So that should be contains, not contains key. So basically, after we've added it, we're going to check to see if it does contain our player. We only add it if it's not there. And if it doesn't contain our player, we add our player to it. So if this location does not currently contain the player we are trying to add, then add the player to it. Okay, very good. So I'm going to go back over the player manager now real quickly. I'm going to make a public world location variable, and this will just keep track of what location they're actually in. So we're going to say area they're currently in. And I am looking at my other project again. I should probably call that location they're currently in, not area. So we're going to say player.area they're currently in is equal to location, and I'm going to rename that right now so I don't get mixed up because I have it called area in another project. All right, that looks good. Now we're going to do a for each loop, and we're going to go through each of the entries in our dictionaries. So this is going to be a key value pair, and we're going to pass the world location and a list of player managers. And we're going to get this by, you guessed it, iterating through our players and locations dictionary we just made. So why are we doing this? Well, we're going to go through all of these now and check for null entries, because what happens if you have a guy join your game and he leaves randomly or disconnects? His entry in that dictionary is now null, and we don't want that. So what we're going to do is go through every pair. Remember, a pair is the location and the list. And we're going to say if pair.value I is equal to null, value is the list. We're going to say pair.value.remove at I. So we're going to go through each of the lists in our dictionary, and if any entries in them is null, for example, you got a friend who joins, he disconnects, now his entry in that list will be null, we're going to remove it. So whenever we add or remove players to a location, you want to do a null check after all is said and done. So now I'm going to rename this to remove player from previous location. I should say correct the name because I said the name correctly but didn't type it in. Oh, and let's do a null check up here first too. If the player is null when you're trying to add them to a location, simply return. Now we can add this null check to this remove player from previous location as well. So let's yoink that, steal our code and paste it there. Let's also paste the check for the player. If the player is null, simply return. And now it's going to be identical in here, except within this for each loop, what we're going to do, because we want to remove the player from the location, is we're going to say if pair.value contains our player, the player that we're passing, we're going to remove that player. And we do that by simply saying right underneath here, whoops, need another bracket. We're going to say pair.value.remove, and we pass the player. All right, let's save that. Now we can minimize both these functions. Now let's go right below this and make a public bool is player already in the area. So we're going to use this as well, but this is just as the name suggests. We're going to just call this is player already in the area. It's going to check to see if the player is actually already in the area. Let's actually call this is player in area, not already in area. A bit less wordy. And let's call it location. I keep saying area because I'm checking my notes and it says area. Let's call this world location. So is player in location. We're going to make it require a world location variable and a player variable. The bool player is in area is equal to false. And if the player in locations contains key location and the players in locations location. So if the dictionary contains this location we're passing, and the dictionary contains the player in the list, then we're going to say the player is in the area is equal to true, and then we return player is in the area. So basically, one, is this location in our dictionary? It is? Okay, cool. Now, is that player on a list in that location? If they are, excellent. Return is true, otherwise it's false. Now we're going to say private void load scenes around current location. And we're going to make this require a world location. We're going to start by making a list for scenes to load is equal to a new list of type string. The autocorrect is going crazy right now. All right, there we go. And we're also going to make a list of locations. So we're going to say list world location. Then we're going to say this is equal to a new list of world locations. And now we're going to use that function we made in our world location at the very beginning. We're going to say scenes to load is equal to location get all required scenes for this location. So if we go back to that real quick, as you can see, it's getting all the scenes for the location and all the scenes for the other locations attached to it that it needs loaded in. And then finally, we're going to come down here and say if the scenes load.count is less than or equal to 0, return. And we're also going to say right above that actually, if somehow, some way the scenes to load list is equal to null, also return. So we're going to say if scenes to load is equal to null, return. And then lastly, come in here and say world scene manager dot instance dot load additive scenes, and we pass the list we just generated. And that is basically how this system is going to work. So how do we trigger it though? Well, let's first go up here and make a function to kind of bring all these functions in together. And this will be the function that's called from our scene trigger. So let's make this a public void, not private, my bad, load location, and let's make it require a location in the game. And of course, the player who's triggering it, so we can add them to the list. Now, the first thing we want to do is make sure the player is not already in this location. If they are, back out, and we don't want to try to load it again or do anything else. So we're going to say if the player is in the location, we're going to simply return. And obviously this function requires the location and the player. Let's make a comment. If the player is already in the location, do not attempt to load this again. This comment does seem a little redundant since the function is very clear, but I'm going to make it anyway. And then let's go right below that and say remove player from the previous location that they were in. And again, I'll make a comment on this one too, even though the name does already make it very clear, but we're going to say remove player from their previous location. And right below that, we're going to say add the player to the new location. And again, I will make a comment. And then the last step of this function is to load the scenes around the world location. So we're going to say load scenes around world location, and we're going to pass the location that we're passing to this function. So this function, which is going to utilize all these other functions we made on this class, is going to be called from a trigger. Or if you want to like start the player in a specific area when you load into the world. So let's make that trigger really quickly now. What we're going to want to do is go into the project here and create a new script, and the script is going to be called load location trigger. I'm going to delete the start and update functionality as is per tradition, drop in my namespace. And I am going to basically make an on trigger enter function on the script. But before I do that, I make a serializable field for the world location. And this is the location you want to load when you enter this trigger. And then we're going to make an on trigger enter, and we're going to check the collider of the person entering this trigger for the player manager. So we can say player manager, player is equal to other.getComponent player manager. Now, if there is no player manager, return. The only person we want loading scenes or initiating scene loads is the player characters. Now, if the player is not null though, we're going to say world location manager.instance load location, and we're going to pass this location. And that is basically it. We make sure to pass the player as well. And this is how it's all going to work together. Now, this hasn't been tested in this video yet because we're just done writing the functionality. So in the next video, we're going to make a mock-up world, and we're going to make sure all this works together and is functioning correctly. And then we're going to dive into how to make custom colliders that can go around the bounds of your scene. And when it's all said and done, we'll run a little character collider, probably a capsule, through the scene, and it'll show the world loading and unloading as the player moves through it. Thank you very much for watching. I hope you learned something. I encourage you to go on ahead and try to do the rest yourself now. You have all the moving parts. It's possible that I missed something, and if I did, I will correct it in the next video. But the functionality is there, so if you want to go ahead and take a stab at it, I highly encourage you to do so. The next episode will be out next week. I hope you all have a very lovely weekend. Thank you to my patrons for keeping my lights on, and thank you to the people who take the time to leave a like and comment on this series and spread it via word of mouth.